Good morning, good afternoon, everyone. So, let me welcome you all to this second day of the final round of knowledge competition 2025 for the cards domain. We have our esteemed judges, Mr. Sriram Kannan and Mr. Chandrasekhar Ekena. So, let's start with our today's presentations. Our first presenter is Surijit. Surijit, can you start with your presentation? You can start your camera, share your screen, and begin with the presentation.
Yeah. Just a quick check. Am I audible and visible?
Your screen is visible, you are not. Yes. You are visible. You can start sharing your screen again.
Yeah. Now,
All
I'm
right.
ready.
Yes, you can start.
Okay. Okay. So, good morning, everyone. And thank you for joining the session. Today, we will explore how our 16-digit card number, that is our digital identity, actually has smarter and safer twin. I would like to say a token is like a stunt double that takes all the risk and keeps our hero, that is our PAN number, safely off screen. So the topic may sound like bit technical, but I will make sure that I will go with lightweight technical mode. Just a quick note about myself. I had a few years of experience in cards and payments, and I worked across Vision Plus system, different application, EMB processing, or some leading global banks. And honestly speaking, whatever I learned mostly from my colleagues, my peers, my mentors, and a fair number of production issues, some caused by my own code. So next, just a quick look about the evolution of payments. We started with MaxStripe card. Uh, Actually, that and the security that time was kind of a hope and good luck. After that, it was EMB chip that bringing the intelligence into the plastic, and then the NFC made the payments web friendly, and now the tokenization, which gives us invisible armor. Now everywhere it is AI, so how can payments and cards domain be exception? So now AI payment, AI powered predictive authorization, AI powered fraud detection mechanism that even now transaction can think about before they fail. So payments landscape evolved faster than our password nowadays. The main topic now, why tokenization matters. Because tokenization not just a feature, it's a fundamental shift, providing multi-layer of protection and efficiency. It has enhanced the security, it reduced the PCI scope, it prevent the fraud and improve the experience of customer of enabling seamless, secure transaction across various channels, enhancing convenience and trust, and also future proofing our system. You can see now annual card fraud exceed 40 billion according to the Nielsen report. So tokenization is not just a choice or option, I would say. It's for survival. And PCI DSS 4.2 and GDPR already mandated minimal data exposure. EMBCO gives us the framework or the rule book for secure token. I like to say the more we digitize, the more hackers romanticize our data, and tokenization is the best tool or best against that. Now, all tokens are not same. There are different type of token: acquirer token, issuer token, and EMB or network token. Acquirer token basically created within the merchant and acquirer flows environments locally, like the card on file, you can say. Issuer token, basically the virtual card internal basically with the bank, belongs to the bank. And EMB network token, the gold standard. It's globally recognized and managed by global players like Visa and MasterCard. And the uses, basically the uses varies depending on the ecosystems. All are good, I think, but EMB token is the predominantly standouts because of its global recognition, interoperability, and the faster payment experience. I have covered bit about it as part of why tokenization. So basically the PAN transform into the payment token, PAN and PAN expiry date, and a domain bound surrogate identifier that protects the sensitive data or the card data. It reduces the PCI scope, enhance customer experience, interoperability, and complete control over. Issuer has complete control over the token lifecycle. So token is not just a mask, it's a bulletproof vest of our data, basically. And behind the scenes, we have an orchestra that plays the harmony of tokenization, along with the merchant, acquirer, cardholder, issuer, payment network. These are the traditional one. We had two more, that is token requester and token service provider. Cardholder basically initiate all the transaction. Token requester identifies the unique tier ID, the entity, and also helps in provisioning. Token service provider manages the secure vault for payment account number and map it to the DPAN, that is the digital PAN or DAN. Issuer, the financial institution that reviews and approves or declines the token provisioning request and the transaction based on the risk profile and the other authorization checks. Payment network, as we all know, facilitate routing, everything. Majority of the cases now, payment network serve as a token service provider because of their multiple actions. They are globally recognized. Within this ecosystem, the token service provider plays the critical role, acting the central guardian of sensitive payment data throughout the token lifecycle. Token lifecycle, token provisioning initiated, that is the token request. There are some process like token assurance, token generation, token issuance, and token provisioning. So all these steps basically, and the token assurance is ID and V, that is identification and verification is performed. That is via the token requester to token TSP and then to issuer. Issuer validate the transaction. If required, they do for another set of authentication or multi-factor authentication like OTP or SMS. Verified the relationship with the bank. After that only they issue the token. I mean, they approve the token request. Once the request is approved, then the token is generated and stored. That is called the token provisioning. Token is activated, token enabled for use for transactions, and then token processing is done during the normal authorization process. There are other token lifecycle management also, like if required, token can be suspended because somebody wants to travel somewhere or overseas for a few days. They don't want that particular token right now. So they can suspend and resume later. And token deletion, that is the permanent removal of the token. So token vault is one of the major component in this ecosystem, which is basically the token vault manages the DPAN to FPAN, the digital PAN to real PAN, or the surrogate numbers to the real PAN. And the critical data is safeguarded through robust architecture utilizing hardware security HSM. And that token vault actually fortified with multi-factor authentication dual control like maker checker process, so that nobody has the full control on this. There is maker and there is checker. There is encrypted encryption also. It's a multi-layered defense are designed to withstand even the sophisticated threats. Token assurance and domain restriction. That is very important point, because that token assurance level, there is token assurance level. The grade can be basic one, intermediate one, the advanced ones like TAL 1, TAL 2, TAL 3, and domain restriction, like whether which particular domain that particular token can be used, well, and whether this kind of merchant the token can be used. This device will be applicable for the particular token. That is the domain assurance. And cardholder is also authenticated during the IDNV process. Issuer asserted, that is bank confirmed cardholder identity based on the existing relationship. EMBCO different section defines assurance method and determined with the token restriction limit and also token assurance and token restriction limit token to specific merchant channel and device. That is the token domain. There are various type of token services that our network provides. That is the VTS, Visa Token Services. We have for MasterCard MDES. The process is almost same: enrollment, token request, vault mapping, issuer approval, and authorization. Similar like MasterCard Digital Enablement Service, MDES, that's also have the same purpose like the VTS, securing DPAN, FPAN mapping, and also they support both the device base, that is the secured element base, which normally we see in Apple Pay, and cloud-based tokenization like the Google Pay. Apple architecture is, as I mentioned, secured elements. So here the token lives in the, it's a kind of a hardware bound, or the token that there is separate chip or separate hardware in the Apple device that stores the token. Highly secure, and also the biometric, like the Face ID, everything is being provided by the secured enclave in the device itself. So it is highly secure Apple Pay architecture. And there is cloud-based architecture as well for Google Pay. And the cloud-based architecture, basically a cloud-based tokenization model they are using with HEC host card emulation. And they have also a separate trusted execution environment, which provides kind of a, biometric validation during the tokenization process. And the last one, the Samsung Pay, which has kind of a hybrid hero, you can say, that it works for NFC tokenization as well as the secret weapon, the magnetic secure transmission. So even the oldest terminal can say hello to the modern security because of this magnetic secure transaction. So they can work for NFC as well as magnetic secure. That was the older version. Now, just a tale of two tokenization. The mostly use Apple Pay and Google Pay. Apple Pay mainly token storage in secure element, the hardware chip, and Google Pay, the token lives in the clouds. Authentication, Face ID is verified for Apple Pay via the secured enclave, whereas authentication for Google Pay via device unlock and trusted execution environment check. Architecture is secured element based, or it is host card emulation based. But the key message is both achieve the EMB grade task, one through hardware isolation, the other through cloud based. Now the authorization flow, the transaction is initiated, user authenticates, token is generated, and along with the cryptogram, and that is passing through that particular token is passing through merchant to acquirer. And they captured the DPAN and cryptogram, transaction formatted to ISO 8583. Network detokenized via the token vault, retrieves the funding PAN or the real PAN, validates the cryptogram, and then issuer validates transaction details and transaction assurance, approves and decline based on the other authorization checks. Now this is bit technical, like ISO 8583 token fields. So basically ISO 8583 has been reused here. Nothing new for tokenization. For the existing fields are mainly which are already there. We are using as part of tokenization tools. Only difference is data element 2, which was earlier with real PAN, now is token PAN, the digital PAN. That it replaces the actual card number in the transaction and secure overall transmission. The nowhere the card will be published to hackers or intruder. Data element 55, the ICC data contains cryptogram and other fields as well. Data element 123, the token requester ID. There are many other fields. For MasterCard, they use data element 48, sub element 33, subfield 6, 7, 8. There are many others. I just provided some main details like device fingerprint. They had data element 125 for Visa. So many other data elements are there as part of tokenization. These are the major one only.
Surajit, please request you to conclude. Last few seconds left.
Sorry.
I said last few seconds left. Please.
Okay. Yeah. Thank you. Yeah. So the PAR is payment account reference. Now, when I'm talking about the token, now merchant acquirer doesn't know the account number. So if there is some loyalty, some reward point, how they will provide to the customer, PAR is the solution. PAR is some irreversible connection between the primary account. They cannot actually reverse engineer to get the primary account. It is just kind of a reference that will be mapped with the card number so that those entity like the merchant, they can provide the loyalty bonus based on the number of transaction or the amount of transaction the customer is doing with their merchandise. And along with that, some fintech solution provider who can just insight overall spending pattern that can be done using the PAR. Risk management and token assurance I already covered, so I am skipping for now. And now comes the compliance lens, the PCI DSS, GDPR, RBI, all actually saying the same direction that real card number should not be stored. Do not store or stop storing the real card number. And tokenization is the solution. Like it is not only giving the peace of mind for the customer, it also auditor loves tokenization. It cuts their workload as well. Real, now it's not theory anymore. The Google Pay, Apple Pay, Samsung Pay, they are processing billions of transactions every year. And our own RBI NPCI design or framework, a world-class framework for tokenization. And now UPI credit card tokenization that you also can see, that's also with EMBCO aligned. And it's a peace of mind for the customer for the data safety. So I would go for a tokenization versus EMV and encryption quickly because the scope is totally different. Tokenization, PAN replacement, EMV, card present transactions, security, and for encryption, data in transit, they are just encrypting. Future trend, there are future trend in tokenization, like there will be AI-powered risk scoring that will manage the token, that will manage and evaluate the token details. Blockchain audit trail, distributed ledger technology will be used to make it more transparent and tamper-proof. Cloud token API, Visa and MasterCard already working with that, and that will build cloud-native API that manage the overall tokenization process and management life cycle management. These are the reference I have covered earlier. Now, as a wrap up, I can say the tokenization is not just about securing the payment. It is securing the trust, the most valuable currency in our digital economy. So we started with MagStripe and ended with machine learning. So overall, one thing is common or one thing stayed constant. That's the protection of or the need to protect the 16-digit identity that we all carry. So whatever we discussed today till now, I can say no tokens were harmed during this presentation. Only responsibly some tokens are de-tokenized by the responsible token service provider. Thank you very much for your attendance. And now I'm open for the questions and answers.
Hey, hi. Thank you, Surajit, for the presentation. So maybe I'll go with a couple of questions. So um, I think one of your slides spoke about tokenization, EVM, and encryption. So can you explain a bit about uh, which of this is really going to stay and which of the other options are not going to be continuing further?
There
And
is,
why?
yeah, there is two things basically. I don't think one is better than other, first of all. EMB complement tokenization and encryption complement every EMB and tokenization, because even if it is a tokenization is just replacing the PAN to a digital token, but the flow is with EMB also. The EMB data, EMB cryptograph is generated when I'm placing my Apple Pay or iPhone or a Google Pay to a POS. The PAN is only converted, but the process, the cryptogram generation, everything is EMB grade. And encryption always will be there to like TAVV generation or DCVV generation. We need the encryption method. So everything will be there. Maybe if we say the card present transaction nowadays is actually bit less. So in terms of EMB ARQC method, that probably will be little lesser, as the Zen Z or Zen Y, they are going with wearable device or mobile phone, not with the plastic. So that may be little bit less, but nothing is actually better than other. Everything is complement with each other: tokenization, EMB, and encryption.
So, and in the emerging context, you've also mentioned blockchain and AI-based solutions. Now, my next question is, if everything is going to stay, then isn't it going to be a huge adoption challenge of running so many processes and applications to manage all these together, and eventually it's going to make become more expensive and more difficult from the infra perspective and the adoption perspective itself. So how efficient, or not only efficient, how cost effective is this whole process going to be? I mean, it might come at a security, whatever, but doesn't appear to be very cost effective if we have to run three different types of application infrastructures to be able to manage this. How will it work?
I would say that see that EMB is the process of kind of is a framework, like encrypting, generating some cryptogram, and then the issuer is validating that cryptogram. That will be there for tokenization too. So we are building tokenization on top of it. So the infrastructure is already there. The EMB and the encryption is already there. We are making tokenization on top of it just to convert the real PAN or the funding PAN to a surrogate value. So we are not using a different architecture, different infrastructure, I can say. We are building a new features, you can say, which is already using the existing infrastructure. The reason is now the Zen Z, this is payment landscape evolving. So the Zen Z, Zen Y, even nowadays, everybody only carry mobile phone. They don't want the bulky wallet, the normal cash or even the plastics. So only a wearable device, maybe a smartwatch or a phone, that will be enough for any kind of transaction anywhere in the world now. So tokenization is not just I would say a new heavy infrastructure. It is using the existing infrastructure, but it's kind of a converting the real PAN to a surrogate value so that nobody can actually decrypt it during its transmission.
Okay. Chandra, over to you. Thanks.
Okay, thank you. Thanks. Surjit, a couple of things just before we go into the questions. Okay, the first one is the cards industry has started not with Magstrip. It started with ClickClack, the system which we used to rub and then take a carbon copy. I don't know whether you would have seen that or not, but certainly I have seen that and used it. So please take a note of that. The digital journey of the cards has started with a magnetic strip, but actual journey of the cards has started with respect to the ClickClack system. Okay. Second, where did you get all these pictures? They're fantastic. Where did you get them?
I just made it with some stock picture I had already with working with different system, and some are generated with my own APIs, AI APIs that I'm using.
Okay, good. They are quite good and interesting. Okay, now coming to the questions. The first one is with respect to, I want to understand, consider that you...
If you can just give me some time. I'm just connecting my
headphone. Yeah,
headphone, yes.
Take your time. Take your time.
My device is little bit slow. I am audible now, sir?
Yes. Perfect.
Okay. Yeah.
Okay. So the first question is with respect to your saying that there is the tokenization is a very important thing and is a big, what do you say, the discovery with respect to the cards security. Okay. Now, when there is encryption already, when there is hashing, why tokenization takes such kind of a precedence? You can hash the data and send it, and unhash the data, you can encrypt the data and send it, and it actually works. Or you can hash the data, and the same hash can be stored at the issuer so that the card is always secure through the entire journey. Why do I need another terminology called as tokenization and so much of infrastructure around it in order to, like, token service provider, token requester, so many things? Why can't I just go with a hashing or an encryption?
Hashing in terms of you were saying from the terminal itself?
Anywhere. You can, let us take that I'm using the mobile, and in the mobile, when I'm entering the data, etc., with respect to the card number, expiry date, and CVV, I automatically hash it. And the same hash is always stored on the other side of the world. What is that new thing which is there with respect to tokenization?
Yeah, two things. Hashing, what I know is one directional. Like if I hash something, it cannot be reverse engineered. I mean, I cannot.
Hash or encryption, because EMV is about encryption.
Yeah, EMV is encryption, but we have a symmetric key in both parties. Like
keep the same, no? Keep the same here also.
Okay, yeah, encryption will work. Obviously, EMV, I am not saying EMV will work, but EMV majorly work for the card present transaction. Like I have the card, then I'm going to the terminal and using that.
Even in card not present also, why can't I encrypt or hash the data and then transmit it to the other end of the world, which is to the issuer? And issuer will, if it is hash, then they will also have the same hash value. Okay, if I hash your name, it creates 1, 2, 3. And even if you hash also, it will create the same 1, 2, 3. It doesn't create a different thing. Okay, so I can always have the same value. So I may not know that it is for Surjit. Okay, but you will be now given a name 1, 2, 3, which is like a token. But otherwise, if I want to encrypt using a primary and the other key, which is secondary key,
primary account reference.
Yeah, so I can actually use the same and then do the transmission. So why tokenization is so important?
It is the terminology mainly. So when you are saying the hashing, basically you are giving some surrogate values to the card number. Tokenization is doing the same. It gives the surrogate values to the cards and cards, PAN expiry date. It's nothing different from encryption usage. It's just converting the real pen to a different surrogate number. That is useless about the boundaries. So tokenization added a additional value is the domain control and device control. Like particular device will have this particular token. I cannot use a different device bound, to use that token somewhere else. Suppose I have an Apple device or iPhone, I can use that token from the Apple device only, not from that. Even if the token is stolen, it cannot be used outside the device, outside the domain. So this is the benefit tokenization is providing. Similar, the terminology hashing you were using, they also need to go with the same fashion, like changing the card number to a surrogate number, and they must need to be a kind of a domain control or issuer assurance.
Okay, let me just only one more question. Okay, let us take that on my mobile. I have two wallets.
Okay.
Okay, one Google Pay wallet, one Samsung Pay wallet.
Right.
I have one card.
Yeah.
Okay, and that card I added with respect to both the things. Will it contain the same token or will it be different? Same mobile, two different applications, same card.
No, it will be two different token because the application ID is different. It is Google Pay and it is Samsung Pay. So the TR ID, whichever provide, it totally different. So it will provide the two different token, but it will be mapped to the same card number. So like PAR I am mentioned, there may be totally different many tokens, but PAR has a mapping of 1-to-1 with the PAN, the real PAN, the FPAN, but they have made one-to-many relationship with the token. So based on that, merchant, other fintech entity, they can understand, okay, this is the spending pattern of the particular customer, but they will not know the real customer credit card numbers.
So in an ISO 8583 message, if you go to the slide,
Yes.
okay, just a follow-up quickly, okay?
Yes, sir.
No, there will be others waiting, that's why. Okay, so you are saying that D123 is the one which actually is a key in the transmission of, to understand whether it is a Google Pay or it is a Samsung Pay.
Yeah. And also apart from that, there is data element 125, I think for many banks they are using it. That is the device ID, device fingerprint that particular device is using for it. And also the device channels, whether it is a different app, Google Pay or Apple Pay, everything is there. So there will be totally different token. Otherwise, they won't understand which particular device or app is being used, which channel is being used, whether it is a Apple Pay, Google Pay, CNP, CP, those kind of things. So the token will be different if I am using different app, but it can map to a different. It can map to a one single PAN.
Okay, sure. Thank you.
Thank you very much, sir.
Thanks.
So any other questions or any feedback that you want to share? I want to know from the seniors, the payments experts also.
No further questions from us.
Yeah, no further questions. Yeah, thank you.
Thank you. Thank you.
Maybe you asked for a suggestion, so go next time onwards when you are putting the images, please put the source.
Thank you, sir. Source I have actually provided, I mean the research source, whatever I have given. Yes, the images source, as these are new images and from my stock and some are generated from my APIs, AI APIs. So maybe yes, next time I will add that.
Sure.
Amir?
Yeah, Aman.
Sorry, I was Really sorry, I was speaking on mute. So what I was saying is we will invite our next finalist, Ganeshan, who is from our Greenbelt group. Surjit, if you can stop sharing your screen, then Ganeshan
Sure. Just a second.
start his presentation.
Yeah, I have stopped there.
Yeah.
Hi, all, are you able to see my screen?
Ganeshan, your screen is visible. You can start.
Yeah. Hi, all. Good morning to everyone. So myself, Ganesan. So I have 14 years experience in cards and payments. So today my topic is innovation in card payments. So already I think this covered most things, tokenization and everything. So I'm also covering same topic. Anyways, I will share my presentation. So first of all, card payment in innovation nowadays the payment ecosystem involved in the digital journey. Now the bank initially bank mostly dependent on the legacy system, mainframe system, patch dependency will be there. Nowadays the cloud system coming, so everyone using microservices. So instead of, for example, today we are onboarded on card, it will take for 1 day for patch processing. So we can able to activate the card next day only. Now the digital environment comes in play in a very critical role. So real time scenarios coming now. Today, for example, today I will onboard a card. I can within 10 minutes I can onboard. I can able to onboard a card and activate the card immediately. I can do transactions same day. So that how the digital environment now going. So banks are moving in a cloud environment. So whenever the bank moving in cloud environment, the secure will be data also more safest rolling. So now the tokenization is main critical role in the digital environment. So nowadays the payment ecosystem will not advanced technology they are going. So they need to enhancing speed and convenience and security as well. So this presentation explore how the tokenization will happen and advanced security mechanism, how the transferring card payment transaction. So initially, I think SAR already covered a base before Maxip card. One more payments will be there. So our generation, I should know only the Maxip card basic transaction. Nowadays, India also going. Nowadays, mostly Indians, as per RBI, nowadays they are using only chip-based cards. Now they are going to reduce magnetic swipe the card instead of chip card. So based on the security purpose, they are now they are going with EMV only. So most of the now the reduced magnetic swipe card now reduced in India. So other country they are using it, but India now they are going with only EMV cards because of reducing the fraud detection. So now they are as per RBI they we need to merchants not show the card number tokenization though. Now the every issuer and acquirer are coming with the chip card only, and then contactless also come NFC. Mobile phone we have NFC option, enable option we can do contactless, and then RBI also set some limit 5,000 per day. Initially they have started with 2,000. Now they are increasing the security in the card environment. Now they are moving to 5,000. So and then digital wallets also coming. Many wallet coming in the Indians. They are using many wallet. Small merchant they are coming with one wallet like ICFC. They are using PayZap and Google Pay and then Apple Pay and then credit line UPI also coming nowadays. They are ready instead of card using. They are using credit line UPI also coming. So nowadays the fintech companies are focusing on the digital environment, but parallelly we need to focus on our data safe also. So rising cyber threat, breaches in happening in the payment system. So instead of we are using more advanced technology in the bank as well as we need to think about our data safe and then fraud detection from the hackers. So initially when customer before tokenization and all, easily the hackers they are hacking pin range. Based on the pin range they are easily run the algorithm. They are hacking the PAN and then they get in full card number, then they will run the unsecured merchant. They easily do transaction in the fraud environment. Nowadays tokenization coming, we are every PAN number we are storing in the token number. So the cloning, SIM cloning and card cloning and so nowadays are reduced. And then AI also coming, treated the payment trend, how the customer doing transaction every day. And then if you are also putting some AI technology nowadays coming, they are real-time transaction, they are monitoring, they are putting like real-time score, like a medium, high risk. They are monitoring real-time transaction. So like what is tokenization? Already I think Sujit covered most of the things, but my slide actually put overall concept only. Tokenization replace sensitive data like PAN with unique random token. So a token is useless outside its specific context, enhances transaction security. So that is what nowadays we are using tokenization. Like in tokenization, main thing PAN number and expiry date and CVV service code also most important. We need to encrypt the data in transfer, accurate transfer to network and network transfer to issuer. So they are decrypted with the key, and then main role of like converting the data with unique token number, and then like we are using nowadays most people are using in wallet. So device finding authentication also very important while we are doing tokenization. Like nowadays we are device finding coming. Each device we have like a SIM card will be there. So we are doing device finding, and then face ID authentication. Some other multi-factor authentication also coming. So MetaTrader is showing multi-factor authentication also. Like a card user enter during payment, the payment process generates the random token linked to the particular card. A token is stored instead of card details in the merchant system. So nowadays, as per RBI, the merchants store the only token, not PAN, entirely PAN number. So token is mapped back to the original data securely during transaction authorization. So benefits of tokenization like protect sensitive data and reduce risk of breaches, simplify PCI DCS complaints for merchant, and then enable secure recurring and in-app payments like standing instructions of suppose customer do one transaction, they are doing like EMI conversion, and then frequently they are doing transaction with a particular merchant. So merchant will be stored instead of card data, now they are storing token ID. So customer doing transaction, recurring transaction also, it is very safe compared to before tokenization and all. So nowadays the data breaches will not happen like comparatively, but not anyway. Technology growing, the hackers also growing the trends. Anyway, they are still they are doing cloning and all. Even though tokenization happening, they are hacking the system. They are doing like that. But nowadays the cloud system also, like nowadays bank moving to cloud. But cloud also now like Amazon, they are having S3 packet. They are more secure. They are coming with cloud also. So that is what bank technology moving in the digital payments. Like tokenization with encryption, like encryption transfer the data using algorithm and key, and tokenization like substitute of data with unrelated token, no mathematical relation. So initially the encryption happen, right? So process also always easily they are decrypting the data and easily they are getting PAN data and they are doing transaction in unsecured merchant. But both will be like enhanced security, but tokenization offers stronger protection for the stored data compared to encryption. So like after that I come up with authentication like multi-factor authentication and biometric verification analytics. Like each day the AI like machine learning and AI coming for daily, they are getting the data from bank. Their system automatically evaluate the how many transactions per day happen to the particular receiver side, what are the merchant frequently they are using, like how the fraud trend going on. Based on the fraud trend, the AI automatically analyzing, and based on the data they are giving a rule also how we can decline the transaction, how we are put template for particular transaction. So nowadays AI will be doing like initially bank they are having on agent, they are calling the customer, they are confirming the transaction. Now the AI coming, automatically the call will be going to the customer. Suppose customer doing some initially first time they are doing one transaction, system easily identify customer. Now only they are doing for corporate transaction first time. Then initially system automatically send the card to the customer and they confirm the transaction. Now customer doing like more than 50K transaction, the system automatically detect and call the customer and confirm the transaction to unavoid the fraudulent transaction. So real time risk scoring, like based on the transaction and the IP address, we are capturing all the information like which device ID customer they are using, which IP address customer they are using, which location they are, based on the geographical information. The real-time score also happening. Like suppose customer doing on IP address from Pakistan, the immediate risk score will be more high. So immediately transaction will be temporarily blocked, and then we are calling the customer whether you are doing a transaction or not. So nowadays the fraud system also more growing based on the AI and the ML machine learning system. They are improving the fraud system also from the banking sector. Whenever the banking going with the digital environment, as well as they are focusing on fraud detection also. Now initially only issuer only focusing on fraud detection. Nowadays the merchant also focusing on the risk, and they are also monitoring the transaction whenever customer doing transaction based on the geographical information. They are also monitoring whether it's a genuine transaction or fraudulent transaction. Nowadays the technology also moving, so everyone they are monitoring the transaction also. Now tokenization, like nowadays Visa, Master, RuPay have the implemented network tokenization framework. Tokens are used in digital wallets, like initially they cover Apple Pay, Google Pay to secure the transaction. So significant reduction in card data theft and fraudulent transaction. So a feature of tokenization and security, like expansion in IoT and wearable device, integration with decentralized identity and blockchain technology, increasing use of AI for predictive fraud and prevention, standardization of global tokenization protocol. So tokenization is the most secure payment in the nowadays. They are securing the data. Based on the data only, we can prevent the data leakage from other hackers and the fraud environment. So tokenization nowadays a major role in the issuer as well as acquirer and the network also. So tokenization represents the concentration in the evolution of secure card payment. As a technology advance, continuous innovation in security will remain virtual building trustworthy and functional payment ecosystem. So that's all about my innovation card payments slide. So any questions?
Hi. Thank you, Ganesan, for your presentation. Considering the topic, like you mentioned, has a lot of similar points. So I would just like to ask probably a very similar question and see what's your response to that. So in terms of tokenization and its risks and limitations, so can you explain what are the risks and limitations to tokenization?
So tokenization, like initially encryption data, right? So tokenization, like each and every PAN data, right? They are tokenizing with unique token ID for each transaction. So maintaining token ID will be separate for whenever customer doing transaction. Issuer validate the token ID, and then like application transaction count, ATS ID also they are uniquely generated. So based on their information, they are before authorizing the particular transaction. Issuer side they are checking with based on the geographic information as well as the token ID, and then like application transaction counter also they are matching. Like any duplicate will come, they are immediately declaring the transaction, and then based on the risk factor, always they are checking customer transaction pattern, which device ID they are using. Like suppose the customer using different device ID, they immediately a bank will identify they are using different device ID. Before and all they are using a different unique device ID, and then which channel they are using, and the browser also they will easily identify. So based on all the geographical information, issuer identify some risk score, like for example 500 for high, and then 450 risk score for medium, and 200 for low. Based on the risk score, they are identifying whether a genuine transaction or fraudulent transaction.
So I mean, the risk scores are for what? So because I still am not able to get a very clear conclusive answer on what is the risk or limitations. So if everything is going to be, at least what I'm hearing from you is there are pretty clear, solid mechanisms to check any fraudulent issues or any risks or issues. So there are no risks. Is that the case?
Yes, like before and all, like encryption happening, right? That time the hackers are easily identify the PIN number, first 6-digit number. They are easily take it, and they are running on algorithm. They are easily get the full PAN number. Now the tokenization is coming, right? We are creating one token ID with random number, and then hackers also not able to identify particular pin range, which pin range they are using for own acquiring system or ECO system. They are not able to identify which pin range they are using, because every pin range we are decrypting one random number for token number. So they are not able to identify actual PAN number. So they are not able to do cloning those things and all. So we are mostly we are secure the data from the tokenization point of view. So data will be safe compared to encryption.
And in your view, what are the challenges in adoption for tokenization?
Like more challenges was like initially the bank doing like they needed to migrate all the things in tokenization parameters. So whatever pin range they are having already, they need to convert into tokenization. They are tie up with network. They do not do all migration. So whatever initially they are having like key and everything they need to change a different key. So everything they need to set up differently. So initially they are using some SFTP path they are using for the encryption. Now tokenization is coming to in cloud or mainframe they are using whenever they which system they are using. Based on that, they need to allocate accordingly. Which they need to tie up with the HSM. They need to integrate with the HSM and switch also. They need to migrate everything. Initially they are using different key. Now tokenization is coming, everything they need to change. For example, they have 8 million cards or million cards they are having existing. All the cards they need to convert each transaction into tokenization method instead of encryption method. So more challenging factor for, because the customer they want to do any decline for transaction also going well for per day. For example, per day 1 million transaction happening. Now they are doing parallelly, they are doing for tokenization also. So they need to both maintain as well as existing customer also will not affect for the tokenization migration, as well as they need to do safest in the tokenization also. So more challenges will be there, but once settled with the HSM and switch also, they easily can migrate. And but challenges will be there. Bank will move to tokenization. They need to create one SFTP and then they need to create endpoint, API endpoint will be there. So all those things there, but once they are implemented, it will be safe for the further transactions. So, but challenges will be there in issuer side for tokenization.
Okay. Thanks, Chandra. Over to you.
Thank you. Thanks, Ganeshan. Quick two questions. One is with respect to we have so many with respect to tokenization. So I want to focus on MFA. You touched upon the MFA. What do you think about MFA? What is your definition of MFA?
Like NFA, like not like whenever you are doing like contactless transaction, right? So multi-factor authorization nowadays compulsory for whenever nowadays they are onboarding with mobile app only, digital. So whenever they are now other OTP coming for one authentication, and then SIM binding will be there, device binding will be there. So for example, digital onboarding, we enter mobile number initially in the mobile app. So we are getting one OTP. Instead of the time they are doing SIM binding, parallelly they are doing device binding also. That also one parallel authentication for as per RBI regulations. So multi-factor authentication, one authentication will come, and then whenever they are stopping the application in between, they are doing like they are entering personal details. Again, customer go back and apply again apply the application, right? Again, they will do like Face ID or like the pin 6-digit pin or 4-digit pin will ask. So that also one factor of authentication. And then like we are doing like KYC also, right? So whenever we are asking mobile number, we are linked with Aadhaar, eKYC also coming. That also we are asking for OTP. That kind of also one factor of authentication. And then like nowadays they are coming with VKYC concept also coming. So we are not storing for our full Aadhaar number also we are not storing. Instead of Aadhaar number, we are storing retrieval reference number. Transaction also we are using RR number. Same like bank side, they are not storing entire Aadhaar number. Instead of Aadhaar number, they are storing one reference number. So that authentication, like multi-factor authentication, is more important nowadays. Digital banking journey going on. So they are doing like SIM binding, device binding, and then OTP option. So these combination they are doing whenever they are logging the, suppose customer changing one more mobile, again we are doing SIM binding and device binding, and then we will ask all those verification, like we are sending on SMS also parallel. SIM binding they are sending on SMS, customer having some balance, so that they are verifying the SIM finding as well as device finding also. So more factor
Okay.
of multi-factor authentication is more important nowadays for digital journey.
Okay, okay. Thank you. The next one is that you told Aadhaar number, and instead of giving the Aadhaar number, you are giving a reference number, no? You told?
Yes.
So is that a token?
It is not a token like, so Aadhaar wallet, whenever we are entering Aadhaar number, right? So it automatically go to UADA. So Aadhaar, each bank they have their own Aadhaar wallet will be there. In the Aadhaar wallet, they are not storing entire detailed Aadhaar number. Instead of 16-digit or 14-digit Aadhaar number, they are storing retrieval reference number. It is not random number. They are generating different reference number. For example, Aadhaar number will be 1, 2, 3, 4, 5, 6, 7. Instead of 1, 2, 3, 4 seconds, they are storing like a 2, 4, 5, 6. So they are linked with Aadhaar in UADA. Whenever they are fetching UADA taking the reference number with Aadhaar number, but bank said they are not storing actual Aadhaar number. They are storing retrieval reference number. Whenever they are checking for KYC, right, they are checking only for retrieval reference number. They are not checking for Aadhaar number. Whenever they are checking real Aadhaar number, they need to call UADA only. UADA only verify.
Yeah, yeah. Is it not the same like tokenization?
Kind of tokenization only, sir, but like we are generating like card data, right? PAN number, like
So
multiple
tokenization is only for card number, is it? It's not for any other things?
other things also we are doing, like other also kind of like a token method only. But like we are like multiple network will be there, but Aadhaar like only India we are using, right? So that time actual Aadhaar number we are, but I'm not so sure. That is also one kind of tokenization method.
You know
only.
about DigiLocker, no? You know about
Yeah,
DigiLocker.
DigiLocker, yeah, DigiLocker.
When
Yes.
you store your Aadhaar number, what happens in DigiLocker?
DigiLocker also they are converting on reference number only. They are not storing actual Aadhaar actually.
Is it not tokenization?
Okay.
Yeah. Okay. Okay then. Thank
Yeah,
you.
thanks.
Thank you
Thanks
very
for
much.
your-
Thanks.
yeah.
Thanks.
Thank you so much,
Yes.
Ganesh.
Yes, thanks. Thank you. Thank you
Let's
for your
invite
time and thank you.
Great. So our next finalist again from Black Belt is Sudha. Sudha, can you share your screen?
Hi, are you able to hear me and see my screen?
Yes.
Okay, then I'll start. Hi, all, good morning. My name is Sudha Markison, and I'm going to cover today on the topic of like tokenization. So, we are going to see like why we need tokenization and what is tokenization, what are the outcomes, and the different kinds of tokens, and the different players in the ecosystem, and how a token is issued, how transactions are going to flow with token, and the impacts to the ISO message structure, and also the role of the MVCo. To start with, like, so first, like we were doing like payments with cash, and then like we moved over to punch cards, and then like to magnetic stripe. So like when magnetic stripe, like the bank customer like was issued a card, and like they were the card holder now, and like there was a thin plastic card like where the PAN number, expiration date, service code were printed and given to the card holder, and they were like doing transactions with that. But the problem that came with that was like it could be easily cloned. So anybody who captures the information from the magnetic stripe was able to do transactions of their own. So there is PIN, there is signature, but then like if anybody can forge your signature and all, again, like the security is lost. And always like that is that e-commerce transactions where we enter the data in clear, like PAN, expiration, service code, again, like that, the data is compromised. So for card present transactions, the solution was the EMV, where the plastic card, it had a chip and it had the intelligence, it had ICC key. So like we were able to generate a cryptogram using the transaction data. So it helped in the problem of solving like the cloning which happened in the magnetic stripe. But again, in the card not present transactions, the PAN number, the expiration date, service code were in clear. Yes, in case of like card not present transactions, there is like the 3D secure mechanism, but then like that really helps in identifying is the card holder is the one really doing the transactions by means of OTP or one-time passcode and so on. Again, the card data as such, like it is in clear, it is not like secure. And other than this card not present problem which needs to be solved, like and also like the convenience that is desired by the user, like as payment user, like we want to do transactions with a variety of like payment channels and devices, right? Like people want to like store their card number in the phone and want to do transactions using mobile. They want to do transactions with key fobs or rings or like a watch or glass bracelet, whatever it may be. And even like during e-commerce, I just want to store my card in the e-commerce site so that when I go back again, like I want the e-commerce site to recognize me so that like they help me with the easy checkouts. So like we want this convenience. But the thing is, like whenever like we put the card number out in clear in different forms, whenever we take that card out of an issuer issued card, so the security is compromised, because now too many people have my real PAN, expiration date, service code, and all, like in case of e-commerce, and in case of the other mobile wallets and other things, like they have the clear PAN. So the thing is like, and also if the device gets lost, or if the merchant how they store the card on file, if it isn't clear, like we see in the JCPenney, Equifax and all, like the data security, like it's lost. So the security leaves the card. So that is the problem. So one is that card not present, and another one is like the user desire to do the payments on variety of things. So we arrive at a situation where like we don't want to really give out our PAN to every single player out there, but still like we want the convenience of doing the transactions. That is something like we really need something like the PAN, but not really the PAN. And still like we want ourselves to be identified by the issuer so that like they recognize us and approve or deny the transaction. So for this, like the token, that is the answer, because a token is something like where the PAN is like substituted by another value. It's called as a surrogate value. It is called as the token. So it can stand in place of the PAN. It can be used to initiate transactions. So when we come to that part of token, so what happens, like instead of a PAN, I issue a token. But then like if I'm going to use the same token for the variety of things, like for mobile, for ring, for this merchant, that merchant and all, again, like if one time that token gets compromised, like all of my payment channels or devices that gets compromised. So we really want a solution where like every single payment mechanism that I use, it should have a token of its own. So it's not like one-to-one. We want a many-to-one, but still like all the tokens should be tied or pegged to the same PAN. So tokenization as such, so like it's a process of substituting that sensitive information with a non-sensitive information called as a token. And outside of this particular device or like merchant, it should not be like really have any intrinsic value outside of that particular place, because I don't want to compromise, right? Like that's why we have issued like different tokens. So one PAN can be issued multiple tokens, and then like no way it should be traceable back to the PAN. Only a particular entity should be able to figure out the relation between the tone and PAN and the token. So, and then like we don't want any impact to the existing infrastructure mechanism, like because the payment ecosystem goes like merchant, acquirer, card networks, issuer. So there should not be major impact to this existing flow, neither to the message structure. So these are all the things that we wanted. So token, by following that bin sequence and check digit, so it should be following that pattern in order to do that. So like so we are cornering on tokenization as a solution for this particular challenges that we had, which is card not present, and also like storing the card data in a variety of devices. So what's in for a merchant is like now for card on file, they can store the tokens, so that keeps them out of the loop for this PCI DSS, like on all like how they should be keeping the data secure. So even if it is compromised, only the tokens gets lost, not the real data gets lost. So in case of a card holder or issuer, so in case like if a particular payment channel like got compromised, only that token gets impacted, right? So we can temporarily suspend a token, and if we retrieve the card, like we can resume, or we can reissue a token itself. So that cardholder can still have the convenience, but then like the security lapses are avoided. In case of an issuer, if something gets lost, like they need to just replace the tokens. They need not go to the extensive cost of replacing the cards itself. So these are all the outcome, like convenience still is there and security is also there. And coming to the point of like who can really issue the tokens. So there are like already lots of entities here, right? Merchant, acquiring processor, and like card networks and issuing bank. Suppose like if we had that merchant issue the tokens, it can solve the problem of card on file. But then again, the real PAN is like out there in open through all of the rest of the payment flow. In case of acquirer token, it can provide security till here. Again, like real PAN is exposed from this point onwards. In case of issuer token, so it is like all the way, but the thing is like issuer needs to do the heavy lifting, and also like when they issue the token range, like they'll be giving an issuer bin range, and there could be collisions that is acquiring, and also like it might not be interoperable with all the merchants and the payment channels out there. So the best player like who can do this issuing token is your TSP, token service provider. And in our like real market, like it is the card networks itself, like they perform the role of the TSP. So in this case, like we have the token PAN usage till the network, and then like token to real PAN translation can be done by the network or the TSP, so that like issuer is revealed about the real cardholder, so that they can look up the database and do all the cardholder related checks before approving or denying a transaction. So coming to like there are like different terminologies. Whoever like requests for a token, they are called as a token requester, and whoever issues a token, that is called as a token service provider. They are the ones who has to store the token securely in the token vault, and they are the ones who has to provide the translation from the token PAN to the real PAN as well. And issuers, they are the ones like who can verify that the cardholder is the one who is requesting for the token, or at least the cardholder consent is there, like from the token requester. Okay, so each one has its own role. So the token requester, like they need to register themselves with the token service provider, and it needs to be an authorized entity, like who can request a token. For case like Apple Pay, Samsung Pay, and all the wallet servers, like they would be the token requester ID, and the initial 3 digits would be the particular TSP whom they have registered with, and the rest of the one is the token requester ID, which is given to them uniquely, and a token location. And see, like the single token requester itself, they can request for multiple token requester IDs depending upon the payment mechanism, right? Probably they could have provided a wallet, probably they could have an e-commerce site also, probably they could have a branch also, probably Walmart or Amazon, or so they could have an Amazon Pay, and also they can be in e-commerce. So for every single thing, like they can have a token requester ID of their own. Token service provider, they need to verify that the correct token requesters are requesting, and they need to like work along with the issuer to ensure that before the token is issued, that the cardholder is aware of it, do identity and verification checks along with that issuer, and they need to like securely store it. And also like the token generation, they need to like deliver all this like EMV token profile and the token keys which is needed like back to the token requester, and they have to enforce all the domain restrictions that the particular token can be used only by this particular device, only this particular merchant, and so on. So the token lifecycle management, again, like when a token gets lost, or like when a card itself replaced or reissued, or like a stolen card, for all those things like suspend, deletion, and like updating the token expiration date, or like reissuance of the token, everything like they need to work along with that issuer. And then like since like in case of the token thing, usually in case of a EMV card, the EMV keys, the ICC, like that cryptogram is usually generated and then like validated by the issuer. But in this case, the token keys and the profile issuance and all, it is done to the token requester. So the token cryptogram can be verified only by the TSP. Apart from the token cryptogram, all rest, the usual checks like limit checks, balance checks, pin checks, everything it is done by the issuer as such. And then there are like various token service providers, schemes, networks themselves have come up with the schemes. So we have the MDES like MasterCard Digital Enables Services, and Visa Token Service, and Discover and Amex also has on their own. And then like even the process itself, it has its own terminologies. Token assurance, that IDNV, identity and verification, like where we ensure that the cardholder is the rightful owner of the PAN, like before the token is done. So we do check for BIN eligibility, card eligibility, and also the token service provider does a cardholder authentication using a step up like a OTP, one-time passcode and all. And there are like even separate like messages to ensure that PROC code 33 is used for detokenization, and like initially for 100 ANV checks, ABS only checks and all could be used. So here like token eligibility requests, token authorization requests. So those are done like to generate a token, and the token can be issued in an inactive form. And once the cardholder is also verified, the token can be made active. So token completion notification, token event notification, anything related to the token. So like the networks TSPs have their own messages for accomplishing all that. In case of Visa, like that cardholder authentication is like done using an API based mechanism. Generation is like how we generate the token number and the token expiration date. That is the TSP does it. TSP also does the token issuance, that is the delivery of the token related all EMV keys and thing to the token requester. And then token provisioning is the actual delivery. So this is how like it works. Initially, the device requests for the wallet server, like it requests for a token, and TSP, like they, after doing all the IDNV checks along with that issuer, they are the ones like who will generate a token and then like deliver it to the NFC. Initially, the card number is entered, but then on return, like they get the token, which really it is stored in the wallet or the merchant or whatsoever. Then using a token, if they do transaction, all the way from the origination point, be it an e-commerce site or NFC based device or any wallet digital app. So the token travels all the way here along with that cryptogram, and the network, like if it is the TSP themselves, like they can just like check on their own vault and convert the token PAN into a real PAN, and the issuer can do all the checks for authorizing the transactions, and PAN is like returned back, and again TSP converts the PAN into the token PAN, and only the token travels back. So in a legacy transaction, merchant, acquirer, payment networks, and then like issuer, this how the flow is. In case of a token based thing, like so initially the token would have been requested during the generation process, where like after the IDNV checks and all, token is given back to the wallet. And when the actual transactions go, transaction is initiated with the token, and token travels all the way here, and here token to PAN conversion is done using detokenization, and PAN goes to the real issuer. So here like you can see token and token expiration date, that hops, and when coming back, like here everything is given here, and the PAN is also given there. So this is the difference between a normal transaction and a token transaction. And the impacts to the ISO message structure is like in place of the PAN and PAN expiration date, now we have the token and token expiration date. Along with that, who requested for that token, that information is also there, and like token assurance level, and like whether like the token is eligible for a wallet or a COF or like an NFC device. So all that information would be there in that token completion notification, token related that messages. And also like for, we also have a payment account reference number. So that is used to identify that particular card holder for the loyalty purposes, so that the merchant can know like who is the real card holder, so that they can offer all those benefits. But it cannot be used to initiate the transactions, and payment account reference cannot be used to find the PAN. And the impacts of the tokenization is like merchants, they can store it like without, they can store the token without the fear of storing the PAN, right? Like for the PCI-DSS things. And for acquirer and the process, they need to additionally like support the cryptograms, generation of the cryptograms. For TSPs, they need to like work along with the issuers for token issuance and verify the cryptogram instead of like issuer doing it earlier. And for issuers, like they need to ensure that cardholders are aware, and like before getting an IDNV from a TSP, they need to know that they are talking to a valid TSP. And the role of the EMV cores, like they are the ones like who ensures that all range of the TRIDs. So if we go to the EMV core site, like we can see like who are all the registered TSPs, and I'm not able to move the screen up, but there is like bin controller IDs, like all that is registered. So bin controller IDs, it's for the uniqueness of the PAR. and then like a different token assurance method, that is the strength of the IDNV. So everything like it is all the standardization, ensuring the technical framework, and like usage of the pair. So everything like it is done by the EMV. So that is what we have seen. Like so far we have seen like why we need tokenization, and what was the expected outcome, what was the problem that it solves, and how the flow goes, and what are the impacts to the existing message structure. So that's what we have.
Thank you, Sudha, for that presentation.
Okay.
And quite a lot of a pretty detailed explanation. So quite interesting. Thanks. Do you see, I mean, tokens associated with purpose, or tokens don't have usually any associated purpose? Is it used with a specific, each token is associated with a specific purpose for use, or they are mostly token is generic in nature?
For a specific purpose, that's what, like we can have a token for card on file transactions. We can have a token for what is that, NFC based device, or we can have a particular token which can be used for only the wallet based thing. So the token domain restrictions can be done to ensure that a token, it is used only for that particular payment channel. If that is your ask.
So, so each token is eventually getting issued for a particular purpose. So
Yes.
now, in the context of this, who becomes in your, for example, I'll probably refer to slide number 12.
Okay.
Who gets visibility to the purpose through the life cycle?
Like what is the token for, right? TSP, you can know like which is that particular domain. They are the ones who has to reinforce the domain restrictions. So they need to check if this particular token that has come, it is tied to this particular reason against which I have issued earlier in the first place. So they are the ones who has to enforce the token domain restrictions, that this token is valid only for e-commerce, this token is valid only for the wallet and all that.
So in the ecosystem where you have the merchant, the acquirer, the issuer, the network that is supporting it, so nobody gets to know purpose of the token.
Issuer
Only the
also will
TSP.
know. TCP has to enforce. Issuer will also get to know because they get that in the token completion notification, event notification.
Okay.
They have values like COF, NFC, or like wallet based. So they have a values, 3 specific values to know like which particular token this is tied to.
Okay. So the TSP and the issuers get to know.
Yes.
The others don't get to know.
Yes.
What the purpose is. Okay, fair enough. And in terms of token in the context of cards versus tokens in the context of other types of services, for example, in blockchain, is there any difference between the tokenization?
My topic like was specific to EMV tokenization, which is about the cards. But then like nowadays, like tokenization is used for everything, right? Like asset tokenization, like we tokenize things and then like store in a blockchain, like even if it be legal contract or like anything, like it is tokenized and stored. We are moving towards a phase like tokenization of things. So.
Yeah. So I kind of had a similar question earlier to one of the participants. So the challenge or the risk of token adoption versus other methods that exist or might evolve. How do you see tokenization will continue to be adopted and it will continue to be a standard that will be more and more used consistently? There are multiple players. So just in that context of the question, there are multiple players. There are different examples of how tokens are getting enforced these days, and probably the industry is still evolving, and everybody seems to have their own methods. So, and there is a larger challenge of adoption with new, this is only complementing existing capabilities. That means they'll have to build on top of what the existing services are there. So, it's adding to cost, and there is no standardization. And is there something that is really, while the underlying benefit is being put across that this is preventing fraud, it has helped reduce fraud and so on. But tokenization as an adoption, is it going to really stay, and why?
Yeah, see, there are different mechanisms of protecting data, right? One is tokenization, one is encryption, and even hashing was being asked here. So I think it solves each of it solves one problem, right? Encryption, tokenization, it can be used only for structured data, and encryption, it can be used for both structured and unstructured data, and it can protect lots of data at rest. And tokenization is it's used for structured data, and it is we want still that original data to be used by the issuer and all, right? When compare it to the hash and all, so it is mainly used for data integrity. We dump a data and then it produces a small hash. So any changes in the input data, it results in a different hash. So the input data and the hash is sent, and then the receiver also gets that data and computes that hash and compares the computed hash against the incoming hash. That's how it is done. So that
No,
main process for data integrity.
that's a bit of process, but my question really is,
Yes.
what is the how do you think tokenization adoption is simplified, or can be made to be a mainstay going forward if something else evolves? Because adoption of tokenization is expensive. It
Yes,
is
it is.
adding
Token vault is
further
there,
cost.
token request
So
ID.
while it might claim to reduce fraud as a big thing, but if this is suddenly being talked as this is the new industry standard, everybody must adopt. But my question really is that it's coming at a large cost, and what would be the ability for tokenization to still continue as a solution to solve what it is claiming to solve, which is managing fraudulent transactions and give better security for transactions. Why would tokenization be the only answer to all the solution? And if that is the answer, what would be required to make it more standardized and more simplified adoption?
It's education. I think tokenization, it solves a problem for our context. Okay, there are other mechanisms, and we have talked about that. For adoptions, we already have the EMVCo, who has put standards and operations in place, what is expected of a merchant, what is expected of an acquirer, what is expected of an issuer, and all that. So the education and the awareness, and to make everybody aware of what are the benefits, and so that is one way to go.
So your own, when you are going and positioning tokenization as a solution, the general expectation is that every bank and everybody will adopt. Somebody doesn't want to adopt, then what is the mechanism? No, this is the way to go. So is it something that you don't have a choice, you must adopt, otherwise you're going to be left behind? Is that the only reason for token adoption, or is there any better reasons for it?
It's with the cost, whether they want to do it via encryption and all that.
Fair enough.
They have to
Thanks.
choose cost, convenience, and what is the best for them.
Yeah. Of course, it comes with a lot of time and money involved in the process for every player in that. And
there is always that extra thing, right? We need to send out to the token vault, and now the extra processing time and all gets added to that.
The only net benefit that I'm hearing is broadly maybe fraud prevention is a big reason behind it. But what are the other benefits, and why would people want to spend money in this? So that was something that I was trying to understand. But I can gather that this is something pretty much all players are adopting. So all the initiatives are in that direction. Fair enough. Thank you. Thanks, Chandra. Over to you.
Thank you. Thanks, Sudha. It is a different kind of a presentation, what you brought in. So good. And
Can you
also
be a bit loud? I'm not able to hear.
You're
you.
not able to? Can you
Yeah.
hear me now?
Yes.
Okay. Good presentation.
Thank
Okay.
you.
And it's different with respect to the same topic, but it is different. Okay. Now, coming to the two questions, we have touched upon security all the time. Let's look at the data prevention and protection. There are acts around these particular things when it comes to the payment data, and especially with respect to the card issuing data. Are there any kind of limitations which will come when I want to do, because TSP and the other providers who are there with respect to the requester and the provider are the two players in this particular thing. Okay. So will there be any kind of limitations which will hit us when we want to implement?
Will there be any limitations?
Because of the Data Protection and Data Prevention Act of various countries, especially if you look at India and also the UK or Europe, they are actually having a lot of controls with respect to sharing the data, especially the payment and the card related data in another country. So is there going to be any limitations when we implement these kind of solutions, because the TSP and the requester will be located in different countries? Do you see a problem?
Yeah, because see, depending upon who's the TSP, they get access to your real card number as well as the token, right? For example, Visa, MasterCard and all, they are entities operating outside of India. So either the countries needs to take a stand, whether they are going to allow such things where the cardholder data or whatever the thing that is going to be tokenized, whether they are okay in allowing these entities operating outside of the country to have that sensitive information and be the players in converting the sensitive to non-sensitive or non-sensitive to sensitive. So they are doing both, right, in the request as well as during the flow, or they have to come up with their own thing. So in case of India and all, RuPay itself, NPCI itself, that would be having the token vault or the TSP. So it depends upon where do we want, who we don't want to have the domination of doing this tokenization or the detokenization. So depending upon the country and its laws, whom they allow to serve as a TSP, that would have a say.
Okay. Okay. Now, given an opportunity, if at all, if you have to say that, okay, it's not tokenization, but I would like to go with another thing, another solution, what may be the one which you would like to think through? There are three solutions. One is to do the encryption. Second is to do the hashing. Third is to do the tokenization. Is there anything which you would like to think through to make a better solution?
Like I already told, it solves each solves a different problem, right? Encryption is you are encrypting the data so that it converts into a ciphertext. And in case of token, it converts into another form. It is still readable, but then not the real data. Hashing is a big chunk of data is given and it converts into a small integer or something, by which that helps in data integrity to ensure that the data is not tampered. In case of encryption, again, it helps in the data security, but then it can be irreversible. It can be reversible as long you know the key, right? So here the key, it needs to be protected at all cost. And in case of tokens, the token vault, that needs to be access to the token vault, or who can tokenize or detokenize, that it is the main thing, right? So this helps in data integrity. Encryption helps with the data in transit, data in storage, data at rest and all, it helps. But token as such, it helps there, but it is if somebody gets an access to the token, it is of no use. They need to have access to the token vault and tamper the token vault itself. So that is like the primary thing. And again, like there is structured data and unstructured data. Tokenization can only work on structured data, but encryption and all, it can work on both structured as well as unstructured. So it depends upon what is the solution I want, what is that I'm trying to accomplish. Am I like interested in data confidentiality or in ensuring data integrity, or like do I want the convenience of like knowing what was the original? So in case of token, in case of like hash, you cannot get that original thing. You can only compute the same hash. But in case of token vault is the one which can retrieve the original data for me.
Yeah.
So
So
still,
let
if I
us think
want
that
yes.
let us think that the token vault has gone down. Like you have seen very recently, AWS has gone down. Then Microsoft Office Outlook has gone down because they're all the cloud service providers. So if the TSP is gone down, then entire payments and I can't do anything, is it? So what do you
Yes.
think about the solution then?
Probably they should have like fallbacks, but then like once we have tokenized and have it, like that is the only way of initiating a transaction, right? We can't go back like initiating the transaction to the old form. So whoever is the TSP, they need to have ensure like disaster recovery mechanisms and the other things. Because once something is implemented, now the token is only there in the COF or card or the NFC. Now I can't go back and choose some other mechanism. So if we have chosen token as the thing, then we need to ensure the availability of the token vault by looking at the disaster recovery mechanisms, backups, and all rest.
Okay. Okay.
Otherwise, we
Thank
should
you.
have thought of the solution before adopting it.
So banks have this opportunity, no? Okay. Yeah. Thank you. Thank you. Thank you.
Yeah.
That is where EMV, the alternate solutions can come. But thank you. Thank you very much. Thanks for very good question.
I just wanted to add on that. So, do you believe there are offline methods that can be adopted to manage this, especially to the question that Chandra asked about when the token vault goes down? Do you believe there are offline methods to that can be adopted to solve that problem?
Probably issuer can give their own wallets and like allow the cardholder to do the transactions. So different ways of doing the transaction.
I think maybe point to ponder, but yeah, thanks for that. Yeah. Okay. Thank you.
Thank you so much, Sudha. Let's move on to our last finalist for today, Yogesh.
Yeah. Give me. I'm sharing my camera. Right. You are
Yogesh, your voice is breaking in between. I'm not sure if it is only for me.
right. Okay. I have started my screen sharing. I hope it is visible now.
Yes, we can make it to full screen.
Yeah, sure. Okay. So before we start, right, let me introduce myself. My
Yogesh,
name
sorry
is
to
Yogesh Lavande.
sorry
I
to
have
stop you in
total 30
between,
years of experience in cards and payment.
but I mean, we are not still
Yeah.
able to see the full screen.
Oh,
Maybe you have just shared the presentation, not the entire screen.
Hello?
Yeah, now you can just present it. I mean, in the sense, make it full screen.
Okay.
Yogesh, maybe right side, your battery showing 66%. For that left side, there is presentation window. You can just click that. Right, left.
All right.
Yeah. All right.
Yeah,
Now,
I'll start. Okay. So I'll be start with payment. As you see, we have card present, card not present channels, right? In a card present, card holder has to have card, right, to perform the transaction, be it a POS or ATM, right? Card holder needs to present the card to perform the transaction, right? On other hand, we have card not present scenario where we see the channels, right? E-commerce, mail order or telephone order, right? This is where actually card holder needs to key in a card number as well as expiration date, right? Which will be actually your real PAN, right? Which you will be inputting to the on the merchant, right? On the merchant page, right? So online, right? This is where actually we enter the card number. And in mail order, telephone order, right? We can dial in the number and we can, key in the card number as well as the expiration date. So the point is, in case of card not present scenarios, we are entering card number expiration date, right? And here card holder doesn't need to present any card, and merchant or attended, you can categorize this channel as unattended channel. Okay, so this is a typical card payment process. So as you see on the screen, right, card holder, here I am taking card present scenario on POS machines, right? So card holder present the card at the merchant will use it, use that card, and POS will initiate the transaction. It will go to acquirer will identify this is offers transaction, and acquirer will send this transaction to the respective network with the Visa and MasterCard, right? And MasterCard will forward it to the issuer. Issuer will validate, right, whether card is genuine, card holder is genuine, and card holder has sufficient balance to perform this transaction, right? So in this whole process, right, we are actually passing PAN details, expiration dates to the, to the issuer, right? So all these parties will have a visibility to this data, and this is like typical MagicStrip transaction, right, wherein we are passing MagicStrip data, be it 35, 45, right? So these details will be passed to the issuer via acquirer and payment network, right? So these are the some security vulnerabilities that we have with the MagicStrip, right? Static data vulnerability, right? This is data is remains static, right? So fraudulent should be able to duplicate or clone this data, right? They can do it because it's static. Once card is issued, right, issuer will not be able to update it. Similarly, PAN exposure, as I mentioned earlier, right, full PAN will be transmitted to the issuer, right? So there is a chance card can compromise. Similarly, cloning, right, there is a possibility where we can fraudulents can clone the cards, right? And the last one is a data breach. For some reason our data gets breached, right, stolen, right? They should be able to fraudulent should be able to make a fraudulent transaction. So these are the security vulnerabilities that we have with the MagicStrip. To answer these issues, right, there is a EME, right? So EME will resolve the issues that we have with the chip transaction. So we'll talk about EME quickly, right? EME is EuroPay, Master, and Visa. It's a chip, it's an open standard for payment terminal and the card to ensure global operability, right, between the partners, right? So initially it was designed by EuroPay, Mastercard, and Visa, and then they form a group, EMUCO, wherein they define and enhance the specification, right? So with the chip, we have these many advantages. has inbuilt processing capacity, right? So chip should be able to process the transaction in offline mode. Again, there is a better security. As you know, during personalization, issuer puts a bunch of keys onto the card, right? And during transaction processing, right, those keys can be retrieved and perform several activities. Similarly, unlike MaxStripe, GME, in case of chip transaction, right, issuer can also post update or sends position commands, right, to block application, card unblock applications, or pin change, pin unblock, right? Those functionalities can be provided with the chip card. And last, contactless pay. So as we know, EMECO has issued 7861 ISO 7816 standard for contact card, and for contactless we have ISO 14443, right? Similarly for NFC we have ISO 18092, right? So these many standards that EMECO has issued for contact as well as contactless, right? So I will quickly move on to the next. So why now, since we have a chip card, right? So why to have EME tokenization, right? So traditionally bank provides EME chip card, right? And that takes a security control or measure, right? Whenever customer performs the card transaction with EME card, right? So in offline, right, chip has a capability to process the transaction between terminal and the card, whereas in case of online, right, transaction will go to the issuer and issuer will perform authorization as well as sends perform a lot of checks on the card and sends a response back to the transaction. So this is for the card present. As you see on the screen, right, we have these many channels, right? If you see be it a mobile payment application, browser based application, key fob, right, Google Pay, right? So this is where actually customer enters the PAN as well as the expiration, right? So there is a risk to keep or leave these Ds, right, PAN as well as expiration date on this portal. So to overcome this, right, there was a need to have a tokenization. Okay, so everybody has talked about the tokenization. So tokenization is nothing but replacement of actual PAN, right? Which will have, if you see the definition, right, it is similar to the PAN. Like in PAN, we have first 6 digit IN, next 11, 12 digits, or you can say 11 digits for actual PAN, which is assigned to that cardholder, and the last one is a check digit. Similarly, in case of token, right, we have a similar bifurcation, I would say, similar data attribute, right? Right. So it's a variable in length, right? But we can have a token similar to the PAN. The point is, right, token is similar to the card, right? But token doesn't have any meaning outside of the wallet application. Yeah. The process of irrelevant, right? Data with the irrelevant data like a non-sensitive equivalent, we call it as a token, right? And it doesn't have any meaning outside of the mobile application or any device. Okay, so we have tokens: acquirer token, issuer token, and event token. Acquirer token, we have already talked about the card on file, right, where merchant enable customer to store the card number for the future references, right? Then we have, let's say customer performs the transaction, that transaction can be converted into the EMIs. Then we have OEM and MNO wallet, right, which can be used to initiate the transaction via different payment channels called QR, NFC, Rapid, right? In-app applications, right? Those perform the transaction, the token, right? So acquirer token, right? Underline we have merchant acquirer token, right? So as we discussed in the previous slide, right, merchant token can be restricted within merchant, right? And merchant should be able to get the actual PAN out of token and send it to the next party that we have. Similarly, we have acquirer token. Acquirer maintains the mapping between token as well as funding PAN or real PAN, I would say. And whenever acquirer receives the transaction, acquirer will perform detokenization and send funding PAN to the next party. Okay. Similarly, we have a issuer token, right? It is similar to the acquirer token. Issuer maintains the wallet, right? And they maintains the mapping between as well as a real PAN. In India, I don't think we have any issuer token wallet, but yeah, this can be used for virtual to RCN mapping, right? Virtual card mapping to real card mapping. So this is where virtual can be, used to restrict the uses, which mainly used for spend control. Again, VCN is similar to token. They allow de-tokenization, right? So with the virtual, we should be able to get the real PAN, our real card number, and spend controlling. And the last one is the EME token, which is similar to the network token, right? We have already talked about it, but I'll quickly touch upon this, right? So with this, I will introduce few more systems that we support for EME tokenization, right? So TSP, right? Token service provided. As you see, it's a three digit in length, right? And as Sudha shown in previous slide, you can see on the EMECO website, right, where we assign the TSP for each and every, TSP service provider that we have, be it Visa, Amex, token, Rupee, right? You'll be able to see unique that will be allocated by EMECO, right? So what is the main functionality of the token service provided, right? So it generates the token, issues the token, perform assurance, right? It also supports token domain control restriction, right? And most importantly, it maintains open token vault, right? This is where actually token versus PAN is stored. Okay. In Visa, we have 8 VTS, right? Visa tokenization system. In MasterCard, we have MDES, MasterCard Digital Enable System. Similarly, you have TIC for MX, right? So the role of the TSP is to maintain the token vault and perform the mapping between PAN and token, perform the token domain restriction services, and most importantly, right, token issuance, right? Underline, we have 4 steps: token assurance, token generation, token issuance, and token provisioning. Okay. Similarly, we have a token requester, right? So token requester is required to get registered with the TSP, right? It is even. So first 3 digit denotes TSP and last 8 digits denotes token requested. It's unique to each application. However, multiple TSP can be, applications can have a multiple token requester IDs with respect to different TSPs. Okay. So this is the token requester and token domain restriction control, right? So basically it talks about the uses of the token, right? So it restricts the uses of the token with respect to the channel, merchant, device, and initiator. So token can be channel specific, merchant specific, device specific, and initiator specific. However, you can see the different uses, right, with respect to different channels, right, in the screen. But yeah, to highlight, right, token can be a channel, merchant, device, and initiator specific. Okay. So token issuance process, right? So typically in token issuance, we have verification, right? So this is where token requester closely work with the TSP to ensure like PIN is eligible for tokenization or not, right? So token TSP has the information to see, right, whether BIN has enrolled for tokenization or not, right? So this is the eligibility and verification. Second one is customer authentication, right? So okay, so first one, availability. This is where requester works with the TSP to check BIN is enabled for tokenization or not. Second one is a card eligibility. So TSP works with the issuer to see, right, whether card is genuine or not, right? And the last one is the step up process where customer authentication gets performed via OTP or different channels that we have. Okay. So similarly, if it comes to TSP or network specific, right? So Visa and MasterCard, right, they have token eligibility, right, followed by token authorization request, and they have so many message function like token completion event, token acknowledgement event, right? So for eligibility check, right, MasterCard sends ASI or token authorization request, and when it comes to authentication, so they send the token completion event, right? Similarly, for Visa, we have EVS followed by token eligibility request, and through API or through token authentication request, right, they can validate the customer. So these are the key security features that we have with the tokenization, and that we have already talked about it, right? So I will quickly explain the flow, right, how token gets issued, right, for the contactless, or for this token, actually how it gets issued. Okay, so first one is right, when we have NFC enable mobile, right, with that customer or token requester can request for token. It actually passes that request to the TSP, right? TSP forwards the PAN to the issuer to get the card authenticated, right? And where actually issuer sends a response back to TSP, right? And once it reaches back to TSP requester, right, issuer sends or performs cardholder authentication with the different channels, be it OTP or PIN, right? They can validate the customer to ensure like it's a legit customer. Okay, this is how
Yogesh,
actually
request
it
you
gets
to move quickly
token.
as time is almost left. Time is almost over.
Hello.
I said you can please quickly conclude as time is already up.
Sure. Yeah. And tokenization transaction processing, right, as you see on the screen, right? So customer sends token to the merchant sends token to the acquirer, right? And acquirer sends a similar token to the TSP maintains the token vault. This is where actually they get the token PAN against the token. They also perform token cryptograph services and sends a real PAN to the issuer along with the service result. Okay, and issuer will simply perform or checks the card and cardholder authenticity and sends response back to TSP. TSP again will swap between PAN and token and sends response back to merchant. Okay, so this is the typical flow. Traditional flow and tokenized flow I have already discussed, but I will not go into. And the last and most important field is payment account reference, right? So if you see in typical tokenization transactions, right, so we send funding PAN, be it a mask or last 4 digit of the PAN, right, which will be sent to the merchant in the response message. In the MasterCard, we have 4033 where we send this detail. But with this detail, right, merchant will not be able to perform analytics. There are some, if it is their merchant specific loyalty programs, right, they won't be able to perform with the PAN that we are passing on to the merchant, right? So practical application for which there was a need to have one more field, right, which can be used to perform this many operation. So PAR is the answer for that. It's a unique non-financial identifier which will be linked to PAN. It's a one-to-one mapping with the PAN. It's a one-to-many mapping with the token that we have, as you see on the screen, right? And if you see the definition of it, right, so it's a 29 character in length. First 4 character are BIC, right, and the last 4 are like specific to the PAN. This PAN service is configured against the funding PAN or real PAN, I would say, right? So with this, right, in a MasterCard we have something called D56 where it carries the PAR and send it to the acquirer, and on system, right, on merchant side, if there is any analytics that they need to perform, if there is any loyalty program, or if there is any value added services, right, with this field they should be able to provide the services. These are the some benefits that we have with the tokenization, right? Enhanced security, we are replacing sensitive data, right? PAN token. Similarly, we have fraud reduction. There will be a domain control restriction that we are applying. There will be a less, I would say, scope to the PCI DSS, because we are replacing PAN with the token, and as we discussed, token cannot be reversible, right? So we cannot trace the PAN based on the token, right? So these are the some benefits that we have with the tokenization, and yes. So with this, I'll conclude. If there is any question, please let me know.
Thank you, Yogesh. So maybe question to you would be, how adoption of tokenization is going to help in dispute resolution. Is that something that you see as something that will help in dealing with dispute resolution in a better way? How does
Yeah.
tokenization really help?
Okay, all right. So in dispute resolution, right, we have so many cycles: first presentment, chargeback, right? So first presentment, it comes from acquirer, and this is where again acquirer should present token, right? Again, when it comes to TSP, they should perform the PAN mapping and to get the PAN, real PAN against the token and send to the issuer. If there is any use case for the chargeback, right, issuer will receive the token, right, in the request in their original request message, which is there in the presentment, right? But when it comes to chargeback, right, issuer needs to send a pending PAN. Okay, and again, when it comes to TSP, right, TSP needs to perform the tokenization and gets the token and sends it to the acquirer in a first chargeback, right? So to answer your question, even in dispute life cycle, there is a need to perform the tokenization.
No, so through tokenization, I'm sorry, I might have missed that last thing. It was a bit shaky, the connection. Can you repeat your response, please, if you don't mind?
Okay, sure. So in the first presentment, right, we, as we know, in case of clearing, right, we send acquirer sends a token, right, and when it's received by network or TSP, right, they need to perform the PAN mapping against. Obviously, there is something called auto clearing. There, they can pull the funding PAN from auto clearing match and enrich the funding PAN or real PAN presentment to the issuer. Similarly, whenever issuer raises a charge, again they should send a PAN in D2 or in clearing file. Again, as I mentioned in the cycle, there is a way like be it auto clearing match. They can pull the data from authorization message itself, or they can perform token for clearing route. In a dispute life cycle, there is a need for the detokenization, right, by the respective parties can get the details, right, and they get their dispute management.
Okay. The voice was a bit shaky, but what I've gathered is tokenization helps in dispute resolution is what I broadly got, but what I wasn't very clear about is how it helps. But the voice was a bit shaky, so maybe I missed out a bit. Second. So
Okay.
So I don't know if the voice is clear. My voice is clear, right, Yogesh, to you?
Yeah. I mean, you are audible. I can hear you. I'm sorry if there is any issues with my voice. Is it better now?
Yeah, it's okay. Yeah, sounds better. Okay, so I'll probably go to my next question. So the in terms of current, token adoption levels, globally, most of the transactions are moving towards tokenization. So are you aware of to what extent tokenization has been adopted globally, and what is the ambition of tokenization adoption for cards?
Yeah. Okay. So if you talk about the payment network, right, there is a by 2030, right, there is a plan, right? I mean, I don't have exact number, right, but most of the cards will be replaced with the token. Is by 2030, I think around 10 billion US cards should be replaced with the token. Again, it's a hypothetical number, but as per my knowledge, right, by 2030 they are planning to replace most of the cards that we have with the token, right? So they want to ensure like all transactions are token based, so that there will not be any involvement of the real PAN in between. So yes, there is a plan from token perspective, network perspective, right? So if I take a example of MasterCard, right, as I mentioned earlier, their plan is by 2030, they want to increase the uses of token, and they want to replace real PAN with the token.
Okay. Fair enough. I have probably one more question. In terms of token being used for offline transactions, does tokenization work for offline transactions, or is it only for online transactions?
When we say offline, it means between terminal and the card or any device, or
When the
you are
network
saying
doesn't
like,
exist. Yeah, when the network doesn't exist, somebody is able to still do the transaction with, of course, the understanding is for that transaction also there is tokenization possible. So is it possible, and is it something that you see coming across in real life examples? If there's any example you can quote, that'll be great. Yeah.
sure. All right. So as you know, right, in typical tokenization transaction, TSP is they play the very important or key role, right, while performing mapping, right? So from network perspective, there should be a multi-resiliency, right? If one side goes down, there should be a secondary side, right, which should be able to, process the tokenization. Now,
That is true.
let's take a
Yeah.
hypothetical
So if
scenario
you're talking
for the
about,
side. Yeah.
sorry, if you talk about BCP or backups, they are still online. So question is, does it work in offline, right? So the system is not there. So
Yeah.
what happens, right? So yeah.
Right. So, okay. So in case of tokenization, right, issuer does not have visibility, right? Well, what is the mapping against between the token and the funding, right? So in case of offline, there is a still way, right, to process the transaction. Like as we say, right, tokenization system or TSP, right? It is mainly owned by the network, right? However, we can have third party as well. Issuer can have also their wallet, right? But for some reason, let's say if TSP gets down, right, they should be able to the token range. Okay, provided, right, as I mentioned earlier, issuer will not be able to know, right, which is the actual PAN, right? So there should be some exchange of the message or the file between the TSP and the issuers, right? So if it gets down, issuer still able to proceed with their authorization with this, right? So as you mentioned earlier, right, there is no way where issuer or TSP or network will get down. But if there is a possibility, right, network issues or some other issues, right, power center data issues, right, so there is a way where even if TSP gets down, issuer should be able to authorize, provided issuer has sufficient information about the token against the PAN that they are maintaining.
Okay. Okay, fair enough. Probably Chandra, over to you.
Yeah, thank you. Thanks, Yogesh. Really appreciate you are the last presenter, but you kept your head cool and you wanted to go through the presentation. We are hearing the same, but you never created that kind of a thing that we had already. So good.
Thank you.
Coming to the questions, I have only one thing which I wanted to first understand. Tokenization, we are telling that it is the most safest. Can you throw some light where it is vulnerable? One situation where it can be vulnerable.
Chandra, sorry, can you please repeat your question? There was some issues with my network. So really sorry for that.
No problem, no problem. Can you tell one particular situation where the tokenization is vulnerable?
Vulnerable. Okay. All right. So this is very hard to answer this question. But presently, in case of card payment, right? So each player, they are responsible for making sure like card details are secure, right? And transactions are passed securely to the to the next party, right? But to answer your question, right, when it comes to acquire a token or merchant token, right? So whenever we store COAP, right, for the future transaction, they need to ensure like tokens or PAN that we have stored, right, is is stored securely, right? But for some reason, right, if their application gets compromised, right? So that would be the problem, because as we see on in earlier slides, right, if there was a data breach, right, where fraudulents have stolen card number as well as expiration date, and with that, right, they were able to perform transactions like anything. Okay, but to answer your question, in case of tokenization, right, EMA tokenization, TSP plays the critical role, right? They have all the information, but yeah, again, in my view, if anything gets compromised upstream, right, upfront before TSP, right, then that's the problem in case of storing the data. However, when we are actually passing real PAN to the issuer, right, issuer also should be able to ensure like they are processing the transaction securely, they are keeping the data securely, right? But at this moment, right, what be it a contactless or NFC enable or in-app applications, right, each party, right, they need to ensure like they process the transaction securely. But yeah, if anything gets compromised in case of storing the data on upstream side, or whenever TSP perform the PAN swap, right, and sends the real PAN to the issuer, they need to ensure like transactions are smooth and processed without any issues.
Okay. So till now we have seen many of the presentations covering on the issuing of the token. Okay. How do the flow happens when it is blocking a token?
Okay, so let's say if there is any life cycle management, right, card gets a real card, I would say real PAN, right, it gets stolen or lost, right? So the respective status will be blocked on
No, not real card. Don't worry about the card block status. Okay. I want to block the token for some reason. Leave the card alone. My card is perfectly there. I want to reissue a token now, a fresh token. Okay. But prior to that, I need to block or remove that, delete or whatever it is. Block, delete, whatever you term it as. But if I have to do it only on the token, how will the journey go?
Yeah, I mean, again, from the token, right, if you want to block that token that we have, right, so okay, as you see in the life cycle, right, it can be blocked from the token requester itself, right? So they can block it, and they can send it to the TSP so that they can also update their status, right? But here, if I understood your question correctly, right, so here what we are trying to say, if how we can block the token, is that the question, right?
Yes.
Yeah. So again, yeah, so as I mentioned earlier, right, if there is any changes in the life cycle for the real card, right, so issuer will be able to communicate to the token requester via TSP, right? And token requester needs to ensure like token is blocked, or they can also perform re-tokenization, right, for different use cases. But yeah, token requester is the one who should be able to do that.
Token requester or the issuer, card issuer?
Okay, so card issuance, right? Issuer will not have the details about the token, right? So issuer will not be able to block it, right? It's a token requester who needs to do that.
Okay. And one last question. If I want to do on a merchant where actually I have created a token as a customer or a card holder, I created a token at the merchant site. Let us take Amazon. Okay. Now I want to perform a EMI based transaction on that card.
Okay.
How do the issuer throw me the details with respect to percentage of interest and other things? Okay. And then the life cycle.
All right. So let's say you have used an NFC application, right, to perform the transaction, right, and you bought something which is like having the more amount, and as a customer, right, you want to split that transaction into the multiple EMIs, right? So it becomes merchant MIT transaction, merchant initiated transaction, subscription based, I would say, or recurring payment transaction, right? So initially, right, when you perform CIT transaction, customer initiated transaction, PAN, you will be able, you will provide the transaction. However, as I mentioned earlier, there was a feature to store the card which can be used for future, right? So in this case, EMI based transaction, right? So merchant will be able to perform subsequent MIT transaction based on the agreement that we have with the customer, right? Like be it a subscription based or EMI based transaction, right? So the whatever agreement that we have, with that, merchant should be able to initiate a transaction on regularly basis. Okay?
Will
So
the merchant be sending the token or what?
yeah. So in this case, merchant, right? Merchant stores the token. Merchant stores the real PAN, as we know, like in typically in India, right? RBI has mandated to have a token for the store PAN, right? Real PAN. So it's a merchant who will send the token, right, to the TSP. Again, for subscription base or recurring payment, there is an indicator which will help us to identify, oh, this is a life cycle message, right? And again, token will be the same, but for the life cycle messages, TSP will perform the BAU. They should be able to get the real funding PAN against the token and process all these recurring or subscription based or CMIT based transaction with the token that merchant has against the PAN which was uploaded by customer.
Okay. Thanks. Thank you. No other questions. Thank you.
All right. Thank you, Abu.
Yogesh, and let me thank everyone here. Let me first start the process by thanking I'm sure by asking multiple questions, the minds, ignited the minds, to use the right word, of all the participants so that they can start thinking more and more about the topics which they have been thinking or maybe presenting. So wonderful way in which both of you have conducted the the competition. So let me thank both of you. At the same time, let me also thank all the participants for taking this active participation. They have gone through a lot of initial testing in the sense they had to go through many rounds, and then from that they have emerged here as the finalists. So let me thank all of them. Let me also thank all the other people who are watching this competition, and also thank my colleagues Ameya and Deepali as well as Kritika for making this competition success. So thanks a lot, everyone. Let me request the judges to share the marks, both of you, with our team, and then we will announce the decision in a couple of days from now. So thank you very much, everybody.